Okay, so first YouTube video for the Concepts of Algebra 2 class. We do have a quiz tomorrow, Wednesday. I'm sorry this is a day late, but I got 6 or 8 problems for us to try and hopefully prepare you for your quiz tomorrow on Wednesday. So let's try this first problem here. It says evaluate each expression for the given values of the variable. And here's this expression and here's your values of your variable. First thing I want to do is simplify a little bit. Okay, so if you look up here, we can distribute this negative into the parenthesis. So that'll create negative k squared minus 3k. Now minus times a minus is a plus 5n, and then the plus 4n just remains the same. And then I'm going to combine like terms. Now these k's have different exponents, so they are not like terms. So negative k squared minus 3k. The 5n and the 4n, they're both positive, so we'll add them together and get 9n. And now I'll do a substitution. I'll replace k with negative 1, replace k with negative 1, and replace n with negative 2. And now notice this right here. This is very tricky. Okay, I'll put it in orange. Everybody wants to make the minus and the minus a plus, but you can't, because this negative 1 is being squared first. So when you square a negative 1, you get a positive 1. But because this negative's out in front, that positive 1 then becomes negative. So this is a negative 1. Minus 3 times minus 1 is positive 3. And then positive 9 and negative 2 is negative 18. So then we will combine them together. Negative 1 plus 3 is 2, minus 18 is negative 16. There you go. So just be tricky with this box right here. Okay, watch out for that. Don't mess it up. Square it first, then apply the negative. Alright, next one, problem 2. Here we go. Write an equation to solve each problem. Aviation, 2 airplanes left an airport at noon. One flew east and the other flew west at twice the speed. After 3 hours, the planes were 2,700 miles apart. How fast was each plane flying? Okay, I always like to draw a picture. So here we go. Here's the airport. A for airport. One plane was traveling east, so that's east, and one plane is traveling west. This is west. Okay. Now, the one that flew west was traveling at twice the speed. So in reality, I'm sorry, the west one, since they're traveling at twice the speed, they went farther. Okay. And the time it took was 3 hours, and they ended up a distance of 2,700 miles apart. So the time they flew was for 3 hours, and the distance is 2,700 miles. So one flew east, and the other flew west at twice the speed. Well, let's let the east speed, this guy, let's have this rate be x miles per hour. So then the guy traveling west was twice that speed. So his rate would be equal to 2x miles per hour, twice. And now I'm going to give you this formula on the test. It's going to say R1 plus R2 times t equals distance. And this is just from the rate times time equals distance equation, but you have 2 rates. These guys are traveling in opposite directions, so the distance is their combined distance away from each other. So your 2 rates are 2x and x. Okay, these 2 rates. So if you want to call this, let's call this, this will be rate 1x, and this will be rate 2x. So to use this equation, the first rate is x, plus the second rate is 2x. The time was 3 hours, so times 3, or just 3 on the outside. And the distance they are apart is 2,700. Let's combine the inside here. 2x and x and 2x is 3x. Times 3 equals 2,700. Multiply, this is 9x equals 2,700. Divide by 9. And x comes out to be 300. So that is the rate the guy east is traveling. So we'll go east. He's traveling 300 miles per hour. Now to get the rate for the west guy, you need to double it. Double 300 would be 600 miles per hour. Okay, so again, I'll give you this formula. Draw a picture, set up the equation, and solve. Next one, number 3. Here we go. Solve each formula for the indicated variable. We have a formula here. Area. I'm going to copy it down right here. Area equals 1/2 b times h. And we're going to solve this for h. That means h needs to be by itself. First thing I want to get rid of is this 1/2. It's a fraction being multiplied, so we would divide by a fraction, but we don't divide by fractions. We multiply by reciprocals. Multiply by reciprocals. So I'm going to take both sides and multiply by 2 over 1. And essentially 2 over 1 is just 2. 2 over 1 is just 2. So on this left side, the 2 over 1, just think of it as a 2. You get 2 times a. On the right side, the 1/2 and the 2 over 1 cancel, and here's my BH. Again, I want to get h alone, so I need to get rid of the b. The b is being multiplied with the h, so divide by b on both sides. And we get 2a over b equals, the b's cancel, and there's h, all by itself. So again, don't be worried about the variables, just think, what is happening? How do I undo it? And that's how you get through the problem. Number 4, we have an absolute value equation. We need to solve it and check for extraneous solutions. Okay? So remember, the first thing is absolute value alone. Is the absolute value alone? Look on the left side. There is nothing outside the absolute value. Yes, it is alone. So now we can start the problem. And the problem is break it into 2. Remember, absolute value can be both positive and negative. So the 2 equations I will set up. Equation number 1. 3x plus 5 is equal to the positive of the right side, 5x plus 2. The second equation I will set up, 3x plus 5 will be equal to, and now I will take the negative of the right side. That would be a negative 5x and a negative 2. So one's the positive, one's the negative, and now we solve for x. On this one, I'll subtract 3x. 5 equals 2x plus 2. I'll subtract 2. 3 equals 2x, and I'll divide by 2. And again, we talked, you can have 3/2 equals x, or you could have 1.5. I don't care. So that is potentially one solution. On the other side, let's solve this one. Let's add 5x because it's negative. Let's make it positive, so we're going to add 5x. That'll give me 8x plus 5 equals negative 2. Let's move the 5 over by subtracting it. 8x equals negative 7. And let's divide by 8. And again, this is negative 7/8, or you could have negative 0.875. And now we need to check for extraneous solutions. That means plug these in, and really, does the right side come out to be negative? Because an absolute value, okay, the rule is, an absolute value cannot equal a negative number. So if the right side comes out to be a negative, the absolute value would never pop out a negative number. So that's what we're checking for. Check for this. So let's do it down here. So the equation's up there. So we have absolute value of 3 times 1.5 plus 5 equals 5 times 1.5 plus 2. And this right side is going to turn out to be a positive number, so I am confident that this is a good answer. Now over here, let's see. We have absolute value of 3 times negative 0.875 plus 5 equals 5 times negative 0.875 plus 2. And I'm going to check that right side in my calculator. Okay, so I'll type in 5 times parenthesis negative 0.875 close parenthesis plus 2. And this right side comes out to be a negative number. And if it's a negative number, you can't have that equal to an absolute value. So this cannot be one of your solutions. So 1.5 or 3/2 is the only solution to this absolute value inequality. So remember, get it alone, get the absolute value alone, break it into 2 equations, the positive and the negative of the right side. Typically it's just the number. Here it was an expression, positive of it, the negative of it, and solve. And then if you see those directions for check for extraneous solutions, you better do it. Okay. Here we go, 5. Solve each inequality, graph the solution. Alright, so again, same question. Is absolute value alone? And the answer is no. You see that 3? There's a 3 out in front of the absolute value. So we must get rid of that 3 by dividing. Do not distribute. You can't. Those are impenetrable bars, those absolute values. They don't break down easy. Okay, so now we are, yes, it is now done. So now we must create our 2 inequalities. Now, the idea is it going to be one inequality together, or is it going to be 2 separate inequalities? Well, I would suggest you do this on your paper. Draw a number line. The important number is 7. Put 7 and negative 7. Now, either you're going to be, and I'll do this in 2 different colors, either you're going to be, it's equal to, so close dots, either in between, or you're going to be outside. And the idea is from this symbol. This right here, 2x minus 1, must be greater than 7. That is this. So then you must also be less than negative 7. You must be these 2, which is the OR case of 2 separate inequalities. So what I'm going to do is I'm going to create 2 separate inequalities. 2x minus 1 is greater than or equal to 7. Or, now I have to do the left side. 2x minus 1 is less than or equal to negative 7. And we'll solve these separately and graph them again because it's going to change these numbers down here. Alright, so let's see what happens. Add 1. 2x is greater than or equal to 8. Divide by 2. I'm going to slide down a little bit just so I can finish. X is greater than or equal to 4. So there's one of the inequalities. Now we'll do the same steps over here. We'll just get different numbers. Add 1. 2x is less than or equal to negative 6. Divide by 2. X is less than or equal to negative 3. There is our answer. And notice we don't have 7 and negative 7 now. We have 2 different answers. 4 and negative 3. But we'll still graph it the same way. And it should come out the same way. We have 4 here, negative 3 here. They are equal to, with the 4 we go to the right. With the negative 3 we go to the left. And there's our graph. Still separate. So really think about that inequality symbol before you break it apart. Because it's either the in-between case or it's the outside case. This was the outside case. Okay, last problem here, number 6. Write each compound inequality as an absolute value inequality. So here is the in-between case. Alright, right now, okay, and I'll just graph this quickly. Right now, on this graph, you have 27.25, 27.75. This is your min and max value. This is the min, this is the max, and C can be anything in between. So we want to create the absolute inequality that represents that. Well, that means it's going to be a less than inequality. Now remember, we talked about, so variable C. C minus the target, and that's my absolute value bar closed. C minus the target is less than or equal to what's called the tolerance. So we need to find the target value and the tolerance to create the inequality that represents this compound inequality. So let's find the target first. To find the target, we're going to take the max plus the min and divide by 2. So we're taking the average. So 27.75 plus 27.25 divided by 2. What do we get there? I'm going to use my handy dandy calculator. 27.75 plus 27.25 divided by 2 is 27.5. That's right smack dab in the middle. That's your target value. Now your tolerance is very similar, except we subtract the max and min. It's max minus min over 2. So that's 27.75 minus 27.25 all over 2. And that's going to give us 0.25. 0.25. So 27.75 minus 27.25 divided by 2 gives us gives us 0.25. And now we can create our absolute value inequality. The absolute value inequality is C minus 27.5 less than or equal to 0.25. And this is the answer. Now, I would like to quickly, in the last few minutes, I would like to get this compound inequality back by solving this absolute value inequality. And you'll compare it to the original response. So when it is less than, again, what we're doing is we're going to create our number line, and 0.25 goes here, negative 0.25 goes here. We have to be equal to or less than 0.25, so that means this direction. So from the negative 0.25, we have to be greater. That means this is the inside case. This is where you surround the C minus 27.5. You surround it, C minus 27.5. You surround it with those two numbers, negative 0.25 and positive 0.25. And we write this inequality down twice. Less than or equal to, less than or equal to. And you want to get C all alone in here by itself. So we're going to add 27.5 to both sides. Now notice there's 3 sides, so we have to do it 3 times. 3 times. And what do we get? Well, we get 27.25 less than or equal to C less than or equal to 27.75. And that is exactly what you started with in the above compound inequality. So this is the correct answer right here, the absolute value inequality. Hope this video helped. If you have to watch it again, watch it again. These are some of the harder problems. You should be good coming in on Wednesday to take this quiz. Alright, thanks for watching.